Hello and welcome to the talk of the paper Procedurally Generated World for a Zombie Survival Game by Nicholas Dankic, myself Bernard Potocak and Helmut Lavac. Let's just look at what I'm talking about. We will start with facts and goals, a short talk about what the goal of our project was and what's the facts about it, and then the generation of the world, the path generation, area generation, object instantiation and finalization, and in the end a short evaluation and conclusion and a demo of the project. The facts of our project, we thought about the nowadays problems and problems of game development, and that is not even anymore the disk space of the game sizes, but more of a budget. So today games have a big budget, and we thought about ways how we can reduce this budget, and we thought about reducing the costs by generating at least some of the content, if not all, procedurally. But even with the aforementioned resources are not the problem, so like the team sizes and so on, a lot of games today use procedural content generation, or at least some elements of it, in order to achieve a certain level of replayability. And this was our goal of the research. Our goal was producing a playable first-person shooter game utilizing procedural content generation. It should be based on pseudo-random number generators in order to create a small survival world from scratch and achieve at least some level of replayability. And the whole project was made in Unity. Then let's just jump in the implementation part, so how we achieved this goal. Let's start with the path generation. The algorithm of generation of the path is fairly simple. All we need is 2 points, a start point and an end point, with the start point being randomly chosen on one side of the map, or in this case of the terrain, using a pseudo-random number generator, and in the end point of it being calculated from the start point, so that is on the opposite of the map. The algorithm then starts from the start point, calculates the normalized direction towards the end point, and generates a new path point in this direction with a possible offset of 60 degrees, 30 degrees in both positive and negative directions, so that we can achieve these things here, that we have curves and so on, which are also chosen by pseudo-random number generators. And the whole algorithm is an iterative process and ends when the algorithm reaches a very close proximity to the end point. All these path points are then represented as spheres and are saved in a global container for later. Then we came to the area generation. This part of the algorithm places different areas around the path built in previous step. Each area is indicated by a sphere, also like in the previous step, and is defined by a type like an abandoned village or trees, for example, which tells the algorithm what kind of objects are supposed to be found in a certain area. And the size, which indicates the radius of the area. So our algorithm iteratively tries to place areas of decreasing radius onto random points, which is once again chosen by a pseudo-random number generator. And the key constraint here is that the areas are not overlapping with each other, as well as with any of the path points. And the areas are placed in a decreasing size order in order to make sure that small areas do not use up all the space and make it impossible for larger areas to be placed. So the iterative process for placing areas is repeated until the either maximum number of iterations or a maximum number of placed areas of current size has been reached. And both of these parameters are predefined in the editor, with the former being a failsafe against the endless loop. After each area has been placed, its center is connected to a nearest existing path point using the same algorithm previously described. After all areas have been then placed, the remaining space not already occupied by an area is filled with trees, which we will see later in pictures. The object generation uses the areas generated in the previous step, objects are also are generated within it using the same random space filling algorithm like the previous steps. Objects, just like areas, are defined by a type like building, tree, or prop, and the size, of course. And the type of the object generated depends on the type of the area which the object is associated with. Then the buildings are placed first, and trees and props can fill the remaining space. There are currently 3 thematically different building types that can be generated, and the maximum number of the objects generated in each area depends on the size of the area. So if the type of the area is a village, for example, and the area is large enough to have 2 or more buildings in it, then each of the buildings generated is also connected to the nearest path point. In this step, only the informations are saved, so there's nothing instantiated yet because of the important step, which is the next step, which is about the terrain alpha maps and height maps. The terrain uses 2 textures, a dirt texture for the path and a grass texture for everything else. Here the alpha maps are generated by going through the terrain points, and if a certain terrain point intersects with a path point sphere, the texture for the terrain point is set to dirt, and if there's nothing, or better said otherwise, it is set to grass texture. A randomly generated offset is used here as well when calculating the intersection in order to achieve a more realistic dirt-grass pattern like we can see here in this picture. After that, the heights for each terrain point are set using Perlin noise, which is one of the common pseudo-random number generators techniques as well. And then we can finally instantiate the objects. As before mentioned, there are 3 different types of objects: building, trees, and props. Trees and props are placed in the same way. They are picked randomly, so a random game object of that type is selected and instantiated at positions defined in step 3. Its height, so its Y position, is set to the corresponding terrain height and is also rotated by a random amount around the Y-axis. That's the same case for buildings. They are, however, not rotated by random amount, but are rather rotated so that they are facing the center of the area. So we can see here in this little bit dark pictures, the trees are placed around the path and not on the path, and also some buildings are placed here. Then we are also have the problem that our building assets were a little bit limited, so we decided to use modular assets and combine them with our own scripts in order to procedurally generate different buildings as well. For this step, we used a similar approach to something what was called building blocks framework. So the script would use a previously self-made layout, or better called a template, for the floor, walls, ceiling, and roof, and instantiate random corresponding components at the appropriate positions. So for example, the inside walls can be instantiated as well, which are chosen at random, with the number of placed walls also being random up to a predefined maximum, potentially separating the inside of the building in 2 different rooms in the process, which can be seen here, for example. Yeah, of course we have 2 versions of this script for the 2 different buildings you can see here, and that's it. Then we came to the finalization part. This includes to make the game playable. Grass is going to be placed based on the used texture on the terrain, so if the grass texture is used, then grass and flowers will be placed there. The final step then includes placing the player at the beginning of the path, and placing the zombies around random path points, and placing the objectives, which are pillars, which must be destroyed. These pillars are placed along the path to be more visible for the player. And the last thing we add is the Necronomicon, which must be found by the player as an objective, and it is placed in one of the houses in order to encourage the player to explore the buildings. And that's it. That's it for real now. The game is now playable with a random generated world and objectives for the player to solve. Here you can see a picture of it, of the final version, of the final generated worlds. We also made an evaluation of the game. In this case, we ask a total of 14 users about our game, and these total 14 users played our game a few times and fill out the questionnaire. Before starting the game, we of course briefly explained to them what the game was about, how it works, what they had to do, and finally what the controls are for the character. The questionnaire itself is composed of a total of 12 questions, which are split into categories, the gameplay and the world, with each having 6 questions. Starting here with the gameplay part. There we got some good results for the first 3 questions. The objectives were clear. The testers had no problems controlling the character, and the user interface was also easy to understand. We got some mixed results here from users when asked if they used all of the listed features. This was the case because some users did not bother to explore the buildings that much, so they were unable to find any medkits or ammo boxes. Some users even decided not to interact with the zombies at all, so they did not need any help for ammo pickups, or did they use both of the weapons available. Most of the players had no trouble in completing the game. 11 out of 14 users also agreed when asked whether they enjoyed playing the game, where 2 users replied with neutral and 1 person disagreed, giving this question average rating of 4.07. So overall the gameplay part received good results in our view, and indicates that our goal for the game to be enjoyable was reached. And for the world, we also had 6 questions. We received here some mixed results. The player mostly found it easy to navigate through the level. This indicates that the players were probably almost always aware of the position and could tell at least which parts of the map they have already visited. 19 out of 14 users agreed that they noticed the level to be different each time they played. Only 75% of the users agreed that they tried to explore the map and the buildings, and 9 out of 14 users did not agree that they had no trouble finding medkits and ammo boxes. This could be because they did not explore the buildings, but it could also be an indicator that a purely pseudo-random number generation technique for placing consumable objects is not ideal, or simply that our algorithm had a way too low chance to generating such objects in those places. When asked if they would describe the game as replayable, 10 out of 14 users agreed, 3 were neutral, and 1 disagreed, giving the question average rating of 4.14, which at least suggests that our goal for the game to be replayable was met. So the conclusion for us is we were able to create a whole survival world procedurally and randomly and fit in within a playable game. The user tests provide the game to be enjoyable and replayable, and of course the main conclusion was that the procedural content generation has a lot of potential, which should be without a question further explored. Now we will see a short video about the game, where you can see here the script, the word generator script, with all the predefined parameters. For example, here also the buildings, the zombies, and here the possibility to draw the spheres as well. And I will skip a little bit because of loading times and jump right into the game, which we can see here. You can see that the music plays, the grass is here placed. It is a little bit loud. Maybe we can just make it a little bit more easy. And here we had seen the pillars, and yeah, we can walk around here. Here are the procedural generated buildings. In the one building here is the Necronomicon with the red fog to be a little bit more visible to the players. And then you can see in the left upper corner that the first objective is met. And in the end, we can skip a little bit, we destroy the Necronomicon, and we won the game. So that was it from my part. Thank you for listening, stay healthy, and have a nice day.